basically, for us, it was a case of it is a very important aspect, and that's why I singled that particular question out, because people really do worry about that. And I noticed from the way you asked the question um, that you clearly see that as something that will have an impact on the way the technology is perceived. And I think it is important to address it upfront. I don't think it's something that you want to gloss over. We certainly don't. When we started looking at recognition technologies, one of the ways that was easy to implement it actually was to work with an Amazon or a Google or a Microsoft there's a bunch of companies out there that you pay not even a lot of money to, and you send them videos, or you send them a stream, or you send them images, image stream, and they will interpret that image stream and they will give you identifiers back for the people that you're looking at. So you register someone and then it goes into your database. And then when you see them somewhere else, it'll tell you, oh, that's number 1, that's number 2, that's number 3. And that is one way of doing it. And obviously we looked at it because it's one of the easy ways to get this thing going. But I really didn't like it, because I don't know where else that picture is going. I don't know what other databases these people are running. For all I know, one of the 3-letter agencies will have feedback long before I get it. And I just don't need for that to happen. Certainly not in museum situations or where you have kids involved. I think that's just not right. So what we did is we took a completely different approach, also partly because sending it out over the internet and getting it back works really well when you have a gigabit link. Certainly when you have an uplink that is in the gigabit region. But most people don't have that and don't want to pay for it or couldn't afford it. So we really wanted to get away from all of that and the delays that it causes, because the time from you streaming something to you getting an identifier back can be up to 15, 16, 17 seconds. And obviously, after 10 seconds, I'm standing at the display and nothing has happened. After 10 seconds, I'm at the next gallery, and whatever I'm putting on that screen, I'm long since gone. The sad thing is also that I won't know that I'm gone until 10 seconds later, because it'll take me 10 seconds to figure out that the next stream no longer has me in it. So we really concentrated on privacy and on speed of response. And so with our system, we don't need an internet link, as we've made very clear in a lot of conversations. You can put it in a locked room. Our backend runs or can run SQL. When you scrub an SQL database, there is nothing that is left behind. So it isn't a case of you just take some of the fat table entries away. It's a case of you go through every bit of storage in there and you put random information into it. You overwrite it with random information so that everything is gone. So that is part of it. And then the other thing is that, as you've noticed, we take a face and we convert it into a vector diagram, and then we encrypt the vectors so that the only thing we need to keep is that vector diagram, which is encrypted in order to do anything with it. And then the engine that actually does the comparison works in that encrypted domain, so that you can't even get an unencrypted version of that data out once it's been converted. And so we like to keep people's pictures because it's nice to show that, hey, yes, I'm recognizing you and here you are, kind of thing. So in the lab, we actually do use that in 1 or 2 of our example exhibits, but we don't need to. And the other thing is that the encryption is good enough that if you go from one of our systems to another one of our system and it doesn't use the same encryption key, it won't work. It won't be able to open that vector diagram at all. And then the third thing is that even if you did manage to decrypt it, you cannot take a vector file and recreate a face from it. it's not possible to do that. It's a one-way deal. You can't go backwards. So having done that, we cracked that problem, and that is taken care of. And then the second thing was speed of response. And by keeping the system local and by using a granular approach to the way we build facial recognition systems, our recognition time, well, I should say the time between you being in front of a camera and your media being delivered is always sub-second. And it tends to be between 300 and 500 milliseconds. And we sometimes see 700 milliseconds, but it's not that common. So the speed of response is faster than you'll notice. You walk up to a screen, and by the time you've taken in what is on that screen, we already know you're there and your media is already playing. And that's a really important aspect of the technology in order to make it work. It needs to be that fast. It needs to be that smooth in order to be able to make that work. The other question that I noticed, which is important right now, is does it work with masks? And the answer is that we were in the middle of working on that when we got really busy on a couple of other projects. So we had to shelf finishing it. But yes, it will work with masks, and we are finishing that development work. And within the next few months, we will announce formally that we have that taken care of. So yes, it can work with masks.